Good day, Matric. Today I have a very interesting question with me here. The paper is largely coming from the Northwest Province and it's a trial paper written plus or minus few minutes ago by class of 2024. I think the examiner had a unique, if not a lunatic idea when setting this question. And this is primarily because for the students to be able to do this question, they must have at least a cross-pollination of experience in dealing with double angle identities combined with the brain trust in algebra. Pay attention. 6.5. They say to us, given that 2 to the exponent 2 sine squared of minus 5, 2 to the exponent cos 2x is equals to negative 3. Let's copy that. We are given this situation. That is 2 to the exponent 2 sine of squared of x minus 5 multiplied by 2 to the power cos of 2x is equals to negative 3. All right, where x is in the first quadrant. This part says that x is in the first quadrant. Now, they want us to prove that sine is the same as 1 over the radicand of 2. How do you then do that? So this cos of 2x is a double angle. You can express that in terms of sine only. That's the best thing to do in this case, to say that let cos of 2x to be what? To be 1 minus 2 sine squared of x. That at least you know. And then now I'm going to replace this portion by this quantity here. Pay attention. That is going to be 2 to the exponent 2 sine squared of x, take away 5, multiplied by 2 to the power cos x. But now cos x is now going to be replaced by this. All right. You have 1 minus 2 sine squared of x. That is going to be equated, beautiful people, to negative 3. And I think from here is just to break down the laws of exponents to say that you have 2 to the power 2 sine squared of x, take away 5, multiplied by, if you break that down nicely, you are going to have 2 to the exponent 1, multiplied by 2 to the exponent negative 2 sine squared of x. Now you can bring your 3 this side to have the equation in that particular order. All right, and I think from here, it's just to remember your algebra to say that this quantity here of 2 sine squared is also repeating here. So you can let that to be your k. So basically this is a k method, but in a nice way. Pay attention. I will say let k to be what now? To be 2 sine squared of x. That means in this portion, I'm going to replace that by k. And also this part here is going to be a k. And then we solve this algebraically. Therefore, you have 2 to the power now k. All right, take away. So 5 times 2 is going to be 10 multiplied by 2 to the power negative k. Think about it, all right? And then a plus 3 is going to be equal to 0. So now you can solve for k. How do you do that? So that becomes what? 2 to the power k minus 10 over 2 to the power k plus 3 is equal to 0. You can multiply throughout by 2 to the k. So if you do that, you're going to get 2 to the power 2k minus 10 plus 3 multiplied by 2 to the power k is equal to 0. As a result, that is going to be the same as what? As 2 to the power k to the exponent 2. And then let's say plus now 3 multiplied by 2 to the power k minus 10 is equals to 0. That's how you're going to solve that. And then now you need to let your, you can even factorize this. All right, the way I'm looking at it. Let me just take it to my next page. It's a quadratic, it's a beautiful quadratic equation. So I'm just going to paste it here and say that this can be factorized nicely to say that is going to be 2 to the k, 2 to the k. It's going to be 5. That's going to be what now? To get back to 3. So that should be 2 on the other side, right? So I'm going to say that is 2. And then this should be negative and this should be positive. to get back to positive 3. Okay, with these two. So now you get 2 to the power k is equals to negative 5, or 2 to the k is equals to 2. Think about it. This won't have any solution. So you must say that this one, no solution. Okay, so you must work with this now. How do you deal with that? Remember, what was your k? Your k was this part. That is 2 sine squared of x. So now you are going to have 2 to the power k. But k was 2 sine squared of x equaling to 2. Now the bases are the same, so you can equate the exponents to say that you have 2 sine squared of x is equals to 1. Therefore, you guys are going to get what now? You are going to get sine squared of x is equals to 1 over 2. So let's solve for sine x now. We're almost done. So sine x is going to be equals to plus or minus 1 over the square root of 2 if you take the square root both sides there. Okay, but you need to be very careful. But x is in the first quadrant. That means from 0 to 90 degrees. So that means this is in the first quadrant. You're going to reject the negative 1 over root 2. So your final answer now should be what? Should be sine of x is equal to 1 over the square root of 2. I think this is what they've asked you guys to prove. And this is the best way you guys can attack this question. It was 6 marks.